So we need to know our trig really well for this class. So let's review some of the trig stuff that we learned in pre-calculus and even algebra 2. So sine inverse. So a lot of students just think that sine inverse is the same thing as cosecant of x, and it is not true. Cosecant is the reciprocal of sine. Sine inverse is the inverse of sine, and they're totally different. So cosecant is 1 over sine x. Sine inverse of x is not 1 over sine x. Okay, so they are different things. Sine is different than cosecant, which is different than sine inverse. So just keep that in mind. Sine inverse, if you were to graph it, it's the inverse, so it kind of switches the x and the y values. So remember that inverses switch the inputs to be the outputs and the outputs to be the inputs. So for sine, the input is radians and the output is like -1 to 1. But with sine inverse, the input is numbers from -1 to 1 and the output is radians. Okay. So if you want to think about it like this, on the unit circle, the sign of 0, so think about the unit circle, just kind of draw it right here. Sine is the y coordinate, so at 0 radians, the sine value is 0. Okay, and then sine inverse, it's kind of like asking where does something happen? Where is your sine value equal to 1? And that happens up here. So where does your sine value equal to 1? At pi over 2. And then where does your sine value equal -1? And this is where students get confused. They go all the way around to 3 pi over 2. But sine inverse of -1 is not -3 pi over 2. 3 pi over 2. It's actually -pi over 2. So instead of going all the way around, it's just backwards a little bit. So we want to keep our values close to the close to 0 radians. So where does sine equal -1? At -pi over 2. So sine inverse looks like this. Okay, it looks like part of a sine graph. So again, sine, as you know from graphing on day 1 of this class, looks like this. Okay, and a lot of students think, okay, well, sine inverse is just going to look like this, right? But we can't have that because then it's not a function. So we restrict sine inverse to be only this part of it so that we're not breaking the vertical line test. Okay, so where is sine inverse defined? Sine inverse is defined from -pi over 2 to +pi over 2. Okay, so any number that you plug into sine inverse, the answer should be anywhere from -pi over 2 to pi over 2. Okay, so for example, let's just jump down. Sine inverse of -1. So again, where does sine equal -1? And that happens down here. And we're not going to call that 3 pi over 2 because 3 pi over 2 is outside of our range. Our range is restricted from -pi over 2 to pi over 2. So where between -pi over 2 and pi over 2 is sine equal to -1? -pi over 2. And that is the only answer. You do not have multiple answers. If you plug sine inverse of -1 into your calculator, it's going to tell you -pi over 2. It's not going to tell you 3 pi over 2 and 7 pi over 2, and it's not going to give you an infinite number of answers because then it wouldn't be a function. So this is the important part I want you to know, is the range of sine inverse is from -pi over 2. It's this part of your unit circle, -pi over 2 to pi over 2. Okay, I'll do kind of like another one on the side here. So like sine inverse of, let's say, -√2 over 2. Okay, so sine inverse of -√2 over 2. So where is the y coordinate -√2 over 2? Well, if you think about the whole unit circle, you have a y coordinate of -√2 over 2 here and here. Okay, but we are restricted to be from -pi over 2 until pi over 2. So it's got to be somewhere along this curve here. And that is going to be at -pi over 4. So again, we're not starting at 0 and going all the way around to 7 pi over 4. We're starting at 0 and just going backwards a little bit. It's going to be the shortest distance starting at 0, shortest distance from 0 to get those sine inverse values, okay? So the sine inverse of -√2 over 2 would be -pi over 4. The sine inverse of +√2 over 2 would be +pi over 4. So make sure with your inverses, you should only have one answer, and make sure it's limited to the range that we have designated for these inverse trig functions. Okay, cosine inverse looks like this. So where is our cosine value equal to 1? And our cosine value equals 1 on the unit circle. Cosine is the x coordinate. Right away, at 0 radians, the cosine value is 1. And then where does cosine equal 0? And that happens at pi over 2. And then where is cosine equal to negative 1? And that happens at pi. So cosine inverse, I know this is not exactly to scale, but it looks something like this. Okay, let me move my pi over 2. Looks a little better. Okay, it looks something like this. Okay, so cosine inverse has a range of 0 to pi. So for example, where is the cosine value, cosine inverse of root 3 over 2, means where is the x coordinate on the unit circle, where is it root 3 over 2? So over root 3 over 2 would be right here, and that occurs at pi over 6. Now, does that mean that at 11 pi over 6, you don't have a cosine value of root 3 over 2? No, that's not what that means. Yes, at 11 pi over 6, the cosine value is root 3 over 2, but that's not the question. The question is, what is the cosine inverse of root 3 over 2, which only has one answer, and that one answer is pi over 6, okay? Because that is within our range of 0 to pi. And then I'll do kind of like another one, cosine inverse of, let's say, negative a half. So where on the unit circle is cosine negative a half? Where does it have an x-coordinate of negative a half? And again, it's got to be between 0 and pi. So negative 1/2 for the x-coordinate, that's going to be right here. And that's at 2 pi over 3. Not even though you would say, okay, though the x-coordinate is negative a half at 4 pi over 3, it doesn't matter. It has to be within this range right here for cosine inverse. Okay? And then tangent inverse. So tangent is kind of its own thing, right? It's y divided by x on the unit circle. Tangent looks like this. So you would think tangent inverse is going to look like this, right? Or actually, it looks more like this. But as you can see, that wouldn't be a function. So we have to restrict tangent inverse. So tangent inverse looks like this. At negative pi over 2 and at pi over 2, we have asymptotes. So like the graph of regular tangent, we have asymptotes, but this time they're horizontal, not vertical. And then the tangent of 0 is 0. Tangent of pi over 4 is 1. Tangent of negative pi over 4 is negative 1. And then it looks like this. We approach our asymptotes on either end. So that's tangent inverse. So tangent inverse has a range of negative pi over 2 to positive pi over 2, but we're not including negative pi over 2 and pi over 2 because those are asymptotes. We never actually touch them. If you think about the unit circle, like let's say here we're at 0, 1, right? The tangent would be 1 divided by 0, which is undefined. So we do not include negative pi over 2 and pi over 2 because those we would never actually reach. Okay, so tangent inverse of negative root 3. So where does tangent equal negative root 3 on the unit circle? So here's kind of it's kind of a silly way to remember your tangents on the unit circle. So it's undefined here and here. That's where your tangent is undefined. Okay, here you have the point 1, 0. Well, 0 divided by 1 is 0. So your tangents are 0 here and here. Okay, you should know at pi over 4, 5 pi over 4, 3 pi over 4, 7 pi over 4, those you have the same coordinates, root 2 over 2, root 2 over 2. So those are going to be like 1s and negative 1s, right? So those ones are easy to find. So the ones I just showed you, those ones should be easy to find tangent because it's either 0, undefined, or 1 or negative 1. But we also have like pi over 6, where the coordinate is root 3 over 2, 1/2. We have 2 pi over 3, pi over 3, where the coordinates are 1/2, root 3 over 2. And then when you find tangent, you have to like do a little bit more work, right? So tangent here would be root 3 over 2 divided by half. That's root 3. And then tangent here would be 1 divided by root 3, which is root 3 over 3. So what's an easy way to remember if it's root 3 or root 3 over 3? So at pi over 3, the tangent is just root 3. At pi over 6, the tangent is root 3 over 3. 3 plus 3 is 6. So it's kind of like a quick way to remember. Tangent of pi over 3 is root 3. Tangent of pi over 6 is root 3 over 3. And then, of course, like everything reflects. So at 2 pi over 3, the tangent is negative root 3. At 5 pi over 6, the tangent is negative root 3 over 3. At 7 pi over 6, the tangent is root 3 over 3. At 4 pi over 3, the tangent is just root 3, et cetera, et cetera. So if it's divided by 3 for the radian measure, then the tangent is just root 3 or negative root 3. And you just have to know that from the quadrants. And then if it's over 6, it's going to be root 3 over 3. So that's kind of like an easy way to remember which one it is. So going back to our question, where is tangent equal to negative root 3? That is in this range, right? Okay, so it's negative root 3. So where are my tangent values negative? That's going to be in quadrant 4. And then is it going to be negative pi over 6 or is it going to be negative root 3 over 2? So using the rule we just learned, it's negative pi over 3. Okay, so tangent inverse of negative root 3 is negative pi over 3. So I'll give you another one. Tangent inverse of 1. Okay, so where on the unit circle does y divided by x equals 1? Well, that's going to occur when root 2 over 2, root 2 over 2, because if you divide those coordinates, you get 1. So that's at pi over 4. So you are expected, and that's going to come up a lot this year, and I will yell at you to rewatch this video if you forget, but you are going to have to do problems like 14, 15, and 16 within other calculus problems all the time. So please make sure you know your inverses. Please, you got to know your range. If I say what's the sine inverse of negative a half, you need to know that that's not 11 pi over 6, that's negative pi over 6. And you got to know these things quickly too. You got to know your trig really quick. So you're going to have to practice trig a lot in this class. And if you don't know your trig well, I'm going to be honest, you probably won't do very well in this class because there's so much trig. So please make sure you learn your trig before we get too deep into the school year. And then you realize you didn't know it all along. Okay, so let's let's solve some of these algebraic trig equations. So what I want you to do is treat it like a regular algebraic equation, and then later we will actually do the trig. But at first, let's go ahead and just treat this like a regular equation. And if you need to, some people find it useful to use u substitution. So I see that I have like sine squared of 2x and I have sine of 2x. So if I let u equal sine of 2x, that would be 2. Okay, sine squared would be u squared. And then minus 5u minus 3 is equal to 0. Some people don't need to use u substitution, and it's fine if you can do it without. Okay, and then I'm going to always try to factor before I have to use the quadratic formula. So let's try to factor. So I know it's going to be like this and this equals 0. Okay, to be 2u squared, one of them is going to have to be 2u, the other one's going to have to be u. And then, oh, this is nice. These two numbers have to multiply to be negative 3. Well, there's only one thing that's going to work, one pair, and that's 1 and 3. So that makes it a little bit easier. It's going to be like, it's either 3 here and a 1 here, or vice versa. So I'm just going to guess and check. It's negative 3 and adds up to be negative 5. So I could try like negative 3, positive 1. Okay, that doesn't work. I could try negative 1 and positive 3. Okay, that's not going to work. So let's try positive 1, negative 3. So it's negative 6u plus u. Okay, that works out. So again, figure out like these two numbers have to be the first thing. These two numbers have to multiply to be the last thing. And then when you FOIL it out, the middle numbers need to add up to be negative 5u. So then I get, if you subtract 1 and divide by 2, I get u is equal to negative 1/2. And then here I would get u is equal to 3. So let's remind ourselves what u is now that we have solved for u. Sine of 2x is equal to negative a half. And then sine of 2x is equal to 3. So now let's start thinking about unit circle stuff. So let's actually do this one first. Where does sine of 2x equal 3? So on the unit circle, where do you have a sine value of 3? Nowhere. So that one does not give me any real solutions. So I don't even have to solve that because it's not possible. You can't have sine values outside of -1 and 1. It's not possible. Okay, now where is our sine equal to negative a half? So our sine values are equal to negative a half. So y coordinates are negative a half. So negative a half is a small distance, so down just a little. Okay, halves are small distances, so down just a little. Okay, so that's at 11 pi over 6 and 7 pi over 6. Now notice I'm not limiting my range here because I'm not solving an inverse equation. If you are given an inverse equation, you need to solve with the correct range. But if I'm not given an inverse equation, I am looking at all of my values over the unit circle. So that's, in this case, sine is equal to negative a half at 7 pi over 6 and 11 pi over 6. But I don't just have x, I have sine of 2x. So 2x is equal to 7 pi over 6, and 2x is equal to 11 pi over 6. Okay. Another thing you can do is like kind of use u substitution or like use w, like sine of w is equal to -1/2, then w equals 7 pi over 6 and 11 pi over 6, and then plug 2x back in. So if that helps, you can also use like some other like kind of form of u substitution. Okay, so I have 2x is equal to 7 pi over 6, so x is equal to 7 pi over 12. And then divide by 2, I get x is equal to 11 pi over 12. And if you need to, just double check. If I plug in 7 pi over 12, then I would get 7 pi over 6 after I multiply it by 2. And is sine of 7 pi over 6 negative a half? Yes, it is. Okay. Okay, now here's the thing when you have 2x. That's what makes this one a little bit more complicated. Okay. Sine of 2x has a period change. Okay. The period of just a regular sine graph is 2 pi. But if you have sine of 2x, the period is 2 pi divided by 2, which is pi. What that means is these values, these sine values, will repeat every pi units. Okay, so remember how to find the period of a function, of a trig function. It's whatever number you're multiplying by x inside the sine. It's going to be 2 pi divided by that number. So if it was like sine of 3x, your period would be 2 pi over 3. Okay, so what does that mean? That means you also need to do 7 pi over 12 plus pi, and you have to do 11 pi over 12 plus pi. You have to take the period into account. Now, we're only going to count these numbers if, remember, you have to have values between 0 and 2 pi. So if our numbers are outside of 0 and 2 pi, I will not include them in my final answer. But if you add 12 pi over 12 to 7, you get 19 pi over 12. And 19 pi over 12 is less than 2 pi. How do I know that? Because 19 over 12 is less than 24 over 12. And 24 over 12 is 2, and then pi. So 19 pi over 12 is within my domain. And then same thing with 11 pi over 12. If I add 12 pi over 12, I get 23 pi over 12, which is close, but not quite 24 pi over 12. So this is still between 0 and 2 pi. So I actually have twice as many answers because it's sine of 2x. So that's another way to think about it, is like I kind of expect 2 times the number of answers because it's sine of 2x. So you actually have 4 answers, not just 2, because of that period change. Okay. So again, if you've got sine of like 2x or cosine of 2x or tangent of 2x, you do have to take the period into account, add the period to your current answers, and you might need to keep doing it again. And I can already tell, like if I add another pi to 19 pi over 12, okay, that would be 21 pi over 12. and 21 pi over 12. Oh, wait, I'm sorry, not 21 pi over 12. 31 pi over 12. And 31 pi over 12 is clearly over 2 pi because 31 twelfths is bigger than 24 twelfths. So I know I'm not going to keep adding pi. But you do need to consider keep adding the period until you're outside of the range of 0 to 2 pi. Okay? All right. I think we can do these really quick. 4 cosine squared minus 3 is equal to 0. I'm going to add 3 to both sides. I get 4 cosine squared of x is equal to 3. Divide by 4. Cosine squared of x is equal to 3/4. Now, when you take the square root, you have to put plus or minus. Okay? So cosine of x is equal to plus or minus root 3 over root 4, which is 2. So don't forget, if you take the square root, you have to put plus or minus. Okay, and then there's no period change on this one, so it makes it a little easier. I just have to figure out where on the unit circle is cosine equal to root 3 over 2, or negative root 3 over 2. So cosine is the x coordinate, so I'm going over root 3 over 2, which is pretty close to 1. So where on the unit circle am I going over root 3 over 2? And that's going to be here and here. And where am I going backwards root 3 over 2? Here and here. So remember, a half is a small distance. Root 3 over 2 is large as far as the unit circle goes. Root 3 over 2 is very close to 1. So that is pi over 6. Okay. Here is 5 pi over 6. Okay. Then I've got 7 pi over 6. That's here. And 11 pi over 6, which is here. Okay. So all 4 of these will be my answer because of that plus or minus. If it was just positive root 3 over 2, it would just be pi over 6 and 11 pi over 6. But because I had to do plus or minus because I was the one who took the square root. The square root was not there. I put it there, so I have to put plus or minus and take those into consideration. All right, and then my last problem, this one looks really tricky because there are 4 pieces. But if you have 4 pieces, you should always try to factor by grouping. So factoring by grouping looks like this. Group the first 2, group the last 2. And if you need to do the extra factoring practice that I post, please do the extra factoring practice. So I'm going to factor out a 2 and a sine squared from my first group. And if I divide 2 sine cubed divided by 2 sine squared, I'm left with sine x and then plus 2. And then just double check. If you multiply it out, do you have what you started with? And then here I can multiply out or divide out a negative 1, and I'm left with sine x plus 2. And oh my goodness, I have sine x plus 2 and sine x plus 2. So I can factor out a sine x plus 2, and then what am I left with? 2 sine squared minus 1. All right, let's set each of these equal to 0. So I get sine x is equal to negative 2. Okay, now you already know on the unit circle, can you have a sine value outside of negative 1 and 1? No, so that's not going to be possible. And then I'm going to have 2 sine squared x is equal to 1. Divide by 2, I get sine squared is equal to 1/2. Take the square root. When you take the square root, you have to put plus or minus. The square root of 1 is 1. Okay, and then let's rationalize. I get plus or minus root 2 over 2. And then on the unit circle, this is an easy one, where your sine values equal to plus or minus root 2 over 2. So that's going to be exactly in the middle of each quadrant. So I have positive root 2 over 2 here at pi over 4 and 3 pi over 4. And then I have a sine value of negative root 2 over 2 here at 7 pi over 4. Nope, that's not where 7 pi over 4 is. That's 5 pi over 4. And then here at 7 pi over 4. Okay, so those 4 would be my answers for where sine is equal to plus or minus negative root 2 over 2. So a lot of algebra here, and then you also need to know your unit circle really well.